இது எத்தனை
Hi, good morning everyone. Myself Dr. S. Ravindran, working as an assistant professor in KPR Institute of Engineering and Technology. And today we are going to discuss about the topic electric motors. So one of the interesting topic and very basic topic in electrical engineering. And today I am going to explain you about induction motor and its construction, working principle, and a small comparison with DC rotor. Okay. We will get into this now. As we know, electrical energy generated in this world is more than 50% of the electrical energy is consumed by electric motors. So this is one of predominant electrical equipment which consumes energy for our day-to-day life. And in that thing, induction machine plays a major role because in industry and in our households and everywhere, majority of the motor we use are induction motors. Due to its cost effectiveness, simplicity in control, and also robust in construction, very easy to handle too. And here I have an motor, induction motor of 1.5 HP, and I have just dismantled this electric motor to showcase how it been constructed. Okay. So generally, if it is a motor, we have two parts. One is stator and another is a rotor. Okay. So the stator will be same for induction motor of either squirrel cage or wound rotor. The stator construction is same, but in case of rotor we have two type of rotors. One is squirrel cage induction motor and another one is wound rotor. Okay. So here I have an squirrel cage induction motor. Uh, so this is an rotor. So if you are looking into this rotor, we have few parts. This is a bearing. Bearing is to hold your shaft without touching into your stator. And this rotor construction is very robust because it doesn't require any windings. There is no possibility of getting damaged. This has an end coils or end ring. So it is at both the end of this rotor we have a end rings. Okay, these end rings are short circuiting these copper bars. When you are looking into this, you can see a segments. These are copper bars, and it is also slightly in a twisted manner. It is not in a straight line. It is in a twisted manner to avoid magnetic locking between rotor and stator. Okay. So to make smooth rotation also, it is helping us to get a rotational force. Okay, torque. Okay. So these copper bars are insulated between them, and these copper bars are short circuited at the end so that it gets some closed path between them to get back EMF induced, and so that it will make self-starting, because induction motor is self-starting in case of three-phase supply is given. Okay, this is a simple construction. This doesn't require any winding as I said earlier, and it is very robust. It doesn't require any commutator segments, drawbacks of getting carbon brushes getting reduced, and also sparks. Okay, getting sparks. So it is very robust, very simple, and cheap cost in manufacturing. Look into this stator. So it has three input terminals, which is R, Y, B. If it's a three-phase motor, we have three input terminals. So these are getting inside this stator, and we have a laminated slotted core available for our winding to be placed, and these are laminated thing to reduce eddy current losses. So these windings usually we use lap winding for higher rating and wave winding for lower rating motors. Here they have used lap winding, and you can look into these slots, stator slots. The coils are placed inside the slots, and it's been sealed with some wooden material or plastic material based on manufacturer's comfortability. And these are in casings to close your motor when you are placing this rotor inside it. And when you compare this with the DC motor, the air gap between stator and rotor is very less in induction motor, whereas in case of DC motor the air gap is a bit higher when you compare with these induction motors. So, we have a simple comparison to show with you. This is an one small DC motor rotor, and I think you can have a look into this construction. It is not having any slots over here, but it has a slots and it has a winding, and winding end are connected with the commutators. Can you look into this commutator segments? You can see the commutator segments. Each commutator segments are insulated from each other, and in ideal cases we consider it to be neglected. Okay, and our carbon brush width is considered to be same as our single commutator segment width. Okay, so it will be touching like this. As consider my finger as a carbon brushes with thickness of this commutator segment, and at both the ends it will be just contacting these commutator segments, so that it will supply energy to this coil. Okay, so while rotating it has to continuously keep in touch with this commutator, and due to this segmental change there may be a chance of getting sparks. Okay, so this motor cannot be used in all the places where induction motor works, because these are the drawbacks. We have to replace the carbon brushes frequently, and also there is some chances of electric sparks. It will be dangerous in place of hazardous area. So this is one of a fine motor which is comfortable in all places, and robust, cheap, very friendly in nature too. Thank you.